Good afternoon, everyone. My name is Zahra, and this presentation is going to be on radio frequency magnetohydrodynamic generators. My mentor for this summer was Professor Daniel Lathrop, and I also received a lot of help from Ruben and Artur, so thank you to them. So the motivation behind this project was, in the case of high altitude explosions or natural phenomenon that result in excess energetic particles, in Earth's plasma belts, natural radiation belt remediation wouldn't be fast enough at dissipating these extra energetic particles. And so this increased radiation in the atmosphere would lead to satellite failures in low Earth orbit and in medium Earth orbit, including where the ISS is. So one possible solution would be fitting a device with alternating magnetic fields to the exhaust of a rocket in orbit to produce radio frequency waves which dissipate the plasma faster. So this is shown through the simulation on the bottom right. So there's an alternating magnetic field, and then the plasma, the positive ion from the plasma is the red particle, and that's going to take a different path from the electrons from the plasma, which is shown by the blue particle. So the goal of this project was to build something like this on a smaller scale. So next we got to designing and constructing the device that would be fitted to the end of the engine. So this was a rectangular prism made of ceramic and copper with the dimensions on the bottom left. And so the ceramic was cut using a water jet and the copper was cut using a bandsaw. And this was stuck together using high temperature RTB. And so in all three devices were constructed because after every day of experiments, the device would fall apart. Also, the 4 copper plates on the left-hand side, as seen in the first picture, were connected to electrodes to find the difference in voltage between the opposite sides of the device. So this is what the device actually ended up looking like. So on the right-hand side, you can see that the magnets were lined with the device had 4 magnets on the top and the bottom with alternating polarity. And so the magnetic field inside the device was found. And so that was modeled by the graph on the left-hand side. And so the axis that really mattered and what was going to interact with the plasma in order to produce a voltage was on the x-axis. And so this was this data was fitted to the equation below. Also, the velocity of the exhaust velocity was found to be about 800 meters per second. Then the Lorentz force was used to approximate a voltage estimate. And so equating the E and the V cross B terms, because they were in equilibrium, a voltage estimate was found. And given the spacing of 0.014 meters between the top and the bottom magnets, the voltage should have been sinusoidal in space with a peak around 4 volts. So the experimental setup is shown in this slide. So between each of the terminals at each of the channels, resistors were placed, and this helped reduce the noise. And so I have a video of one of the trials from the experiment. I don't know if you can see that very well. And so here are some of the results. So in one of the experimental trials, 4 magnets were put on either side of the device. And during another one, no magnets were placed and the engine was placed on the other side. And so most of the voltages found were positive. Only channel 2 was found to be negative in the first experiment. There were large voltage variations and the voltages with the magnets were a lot larger than the voltages without the magnets. Power spectras were also found. And so there was broadband frequency signals, which suggest noise, but near the lower frequencies, there was larger power, the power spectra was larger, and so this suggested actual data. So in conclusion, the mostly positive voltages were likely due to the result of an uneven Debye sheath being produced on either side of the device at the copper plates. And so this simulation is shown before. Is not quite what's actually happening in the device. So we assume that the positive ions and the electrons would have the same speed, but obviously in actuality, the electron speed and the positive ion speed would be largely different because of the differences in mass. And so really only the electrons matter. And so the larger copper plate will have a lot more electrons than on the other side, So the voltage difference between both sides would always result in a positive voltage. So the variations in voltage and strong fluctuations were likely due to turbulence and electrode soot deposits. So we tentatively concluded that turbulent fluctuations may produce useful RF power.